Welcome to The Explainer. Today, we're diving deep into the microscopic world of bacterial warfare. We're going to look at the two main types of weapons bacteria use to make us sick. And trust me, they are completely different beasts. You ever think about that? How does a seemingly simple bacterial infection sometimes just spiral out of control and become, well, life-threatening? Turns out, it's not just about how many bacteria there are. That's right. The severity of a bacterial disease really comes down to the toxins they deploy. These things aren't just passive little invaders, they are armed to the teeth. So let's meet the two main players in their arsenal. Okay, first up, let's talk about our first villain, the endotoxin. Now, the absolute best way to think about this one? It's a booby trap, a weapon that only goes off after you think you've already won. And this right here is the heart of it. It's kind of paradoxical, right? The danger from an endotoxin doesn't actually come from the living bacterium. It comes from its destruction. The trap is only sprung when the bacterium dies and breaks apart. So what is this stuff? Chemically, it's a molecule called lipopolysaccharide. We just call it LPS for short. And it's not something the bacterium, makes and shoots out. No, it's literally part of its body. It's a piece of the outer cell wall of what we call gram-negative bacteria. And you can see how that trigger works right here. In step 1, the bacterium is just minding its own business, alive and well, and that endotoxin is totally locked away, completely harmless. But then in step 2, whether our immune system kills it or an antibiotic does the job, the bacterium shatters, and boom, it floods our system with that toxic LPS. And the result of that flood is pure chaos. See, endotoxin doesn't have a specific target. Instead, it sends our own immune system into a total panic, a massive overreaction. We're talking huge inflammation, soaring fever, and dangerously low blood pressure, which can all lead to septic shock. And that is a really, really bad situation. All right, now let's switch gears to our second villain, because this one has a completely different playbook. Meet the exotoxin. If the endotoxin is a chaotic booby trap, then the exotoxin is like a highly trained secret agent sent out on a very specific mission. And that's the key difference right there. These are poisons that are actively made and then secreted, pushed out by living bacteria. They are purpose-built weapons designed to be fired at the enemy while the attacker is still alive and kicking. So, unlike the endotoxin structural material, exotoxins are proteins, and they're usually made by gram-positive bacteria, though, yeah, some gram-negative ones make them too. But the key takeaway is this. It's a protein that is actively secreted. The bacterium is alive, and it is on the attack. So the whole deployment is different. The bacterium basically acts like a tiny factory, just churning out these little protein missiles, and then it launches them into our body to go find their targets. It's a completely different military strategy. And these agents are specialists, for sure. They perform precision strikes. You've heard of these guys. Tetanus toxin heads straight for the nerves to cause those awful muscle spasms. Cholera toxin hits the gut, causing massive diarrhea. Each one has a very specific job, which makes them unbelievably potent, even in the tiniest amounts. So, we've met our two villains, the booby trap and the secret agent. Now, let's do a classic face-off. We'll put them side by side to really hammer home just how different they are. This table really says it all, doesn't it? Let's break it down. Their source, endotoxins, are from gram-negative bacteria, exotoxins mostly from gram-positive. Their composition couldn't be more different. One's a structural lipid and sugar combo, the other is a protein. And that dictates the release, right? On death versus secreted from a living cell. This in turn leads to their specificity, a messy, chaotic immune response for endotoxins versus a laser-focused target for exotoxins. And finally, heat stability. Because exotoxins are proteins, you can often cook them and they fall apart, but that tough LPS structure of endotoxins, way more resilient. Okay, so you might be thinking, this is cool biology, but why does it actually matter? Well, it matters a whole lot, because knowing your enemy's weapon completely changes how you fight back. It dictates your entire medical counterattack. Look, if you remember just one thing from all of this, let it be this sentence. Endotoxins are structural LPS, released when the bacteria die, and they cause widespread inflammation. Exotoxins are proteins, secreted by living bacteria, and they cause very specific targeted damage. That's the whole ballgame right there. And here's the real-world payoff. When you're fighting endotoxins, the main challenge is just trying to calm down your own body's crazy overreaction to prevent septic shock. But with exotoxins, well, because they're foreign to proteins, our immune system can create super specific antibodies to hunt them down and neutralize them. And this is huge. It lets us create things like antitoxins and even better, vaccines. Your tetanus shot? That's a vaccine against the tetanus exotoxin, not the bacterium itself. So I'll just leave you with this final thought to chew on. On one hand, you have a weapon that's a predictable, targetable protein. And on the other, you have a weapon that's baked into the enemy's very structure. A weapon that causes total chaos precisely at the moment you think you've won the battle. It's just a fascinating reminder of how complex this fight against microscopic foes really is.